Hi kids, Mr. Joseph here. I'm going to show you how to do the problems in test review number 1. You should have finished this already before you watch this video. This is just as an added help for you to understand how to do these things. Okay, so let's do question number 1. Which of the following measurements has 2 significant figures? So let's look at each one and find out how many significant figures are in each measurement. So for this one, this first one, this has a period, or a decimal, I should say decimal place, a decimal point is present. So we're going to start from the side of the United States where the Pacific Ocean is, and we're going to count at the first non-zero number and keep counting to the end. Okay, so we're going to see that there's 1, 2, 3 significant figures in this measurement. Also, if you look at this next one, it has a decimal point present. We're going to count at the first non-zero number from the Pacific side. This first number is the 0, so we don't count it. The first non-zero number is the 2. 1, 1, 2, 3. So this also has 3 significant figures in it. All right, let's go over to this option C. This does not have a decimal point present, and so we're going to count from the Atlantic side at the first non-zero number, which is the 3, 1, 2. So this has 2 significant figures. That should be our answer for this question, but it doesn't hurt to go on and just look at how many significant figures in the last one, and you can see that there are 3 significant figures in this because we start counting at the 2 and from the Pacific side because of the decimal point present. So the answer to this first question is C. Let's round off each of these measurements to 3 significant figures. First of all, let's see how many significant figures are in each of these. So in this first one, you can see that there are 5 significant figures. So to get to 3, we're going to round it to this tenths place because we can drop off all the rest here. So it's going to become 98.5 liters. In the next question, we can see that here we have 5 significant figures as well. 5 significant figures. And we want 3 again. So we're going to round it to this point right here, which is the one, let's see, tens, hundreds, thousands, 10,000s, 100,000, the millionths place. All right, so that many centigrams. All right, if we want to go to 3 significant figures here, we're going to say, like the same way this has 5 significant figures, so we're going to go to this. All right, and then the final one, 12.2 degrees Celsius. Using the rules for significant figures, round off each of the following answers correctly. Okay, so they've already done the math for us. We just need to round the answers correctly. So our adding rules tell us that we go to the decimal place that has from one of these that goes into the calculation, we go to the least precise decimal place. This first one goes to the tenths. That's the rounded to the tenths. This is to the hundredths. And this last one is to the ones place, right? Which one of those is the least precise? Well, the ones place, right? So we have to round our answer also to the ones place. So the answer would be 43 grams. The same rule applies to subtraction. And we have this to the tenths place. And the second one is to the thousandths. Which one is less precise? Well, the tenths place. So we got to round our answer to the tenths place as well. 22.58 liters. Okay, when we divide, instead of looking at the place, we look at the number of significant figures in each measurement that goes into a calculation. So in this first one, we have 5 significant figures. The second one, we have 3 significant figures. We choose the number of significant figures that our answer has to be the same as the least number of significant figures in the measurements that went into the calculation. So 3 is less than 5, and so we're going to round our final answer to 3 significant figures. So it's 92.0 kilograms. And you do need to put that 0.0 because you need 3 significant figures in your answer. All right, here we've got 3 significant figures, we've got 3 significant figures, we've got 4 significant figures. So our final answer has to have 3 significant figures, and we're going to make it 32.4 meters cubed. All right, determine the number of significant figures in each of the following. Okay, if we can count numerically something, that means it has infinite number of significant figures. So this has infinite number of significant figures. This has no decimal point in it, so that's absent. We count from the right at the first non-zero number and keep counting. So 1, 2, 3. This is 3. This has a decimal point present, so we're going to count at the first non-zero number from the left. 1, 2, 3, 4, 5. And then this one has 3. Cool. Use an example to explain the difference between precision and accuracy. Okay, so let's see if you had, for example, a thermometer that measured temperature, all right? A thermometer measuring to the thousands place would be precise, but if it measured, say, 51.073 degrees Celsius, and the temp was actually 64 degrees Celsius, then it would not be accurate. So you can be precise and not accurate. You can also be accurate and not super precise, right? What conversion factor would be used to convert from feet to yards? So if we're going from feet to yards, we want to cancel out the feet and end up in yards. So in order to do that, we would have to have feet on the bottom of the conversion factor and yards on the top. And so 1 yard per 3 feet. For example, if you wanted to convert 63 feet to yards, we're going to start with that measurement over 1. We're going to use the unit conversion factor I just constructed. The feet cancel out, and we end up with a ratio of this, 63 over 3 yards. And if we actually do that, it would become 21 yards. So our answer really is this conversion factor. Converting from feet to yards, we would use that. If we wanted to convert from yards to feet, it would be the reciprocal of that conversion factor. Okay, to convert from 100 centimeters to millimeters, we first have to set up the conversion factor between centimeters to millimeters. And we know that means that the centimeters will be on the bottom of the conversion factor, and the millimeters will be on the top. And if you recall, to set up a conversion factor between two prefixes like this, we go to the reference tables and we crisscross the numbers that are next to the prefixes to the other prefix. And so in front of the millimeters, we're going to have 10 to the negative 2, because that's in front of the centimeters. And in front of the centimeters, we're going to have 10 to the negative 3, because that's what's in front of the millimeters on the table. So we're going to convert. We're going to take 100 centimeters, put it over 1, multiply it by the conversion factor that we just made, cross out the terms, that are on the top and the bottom, and we end up with 1,000 millimeters as our answer. A snail decided wants to see the country and take a trip across it. If the snail travels at a rate of 1 meter per hour, how long would it take to travel across the country in years? From Washington, I spelled that wrong, Washington, D.C. to San Francisco, California, if the distance is 4,529 kilometers. Use unit conversions to solve this problem. So we're starting with 4,529 kilometers, and we're going to convert to hours. But we first need to to years. So we have to convert first the kilometers to meters per hour because our rate is 1 meter per hour. So we got to convert this kilometers to meters. And to do that, again, use the reference tables. We know that 1 kilometer is equal to 1,000 meters because the K equals 1,000, right? Okay, now we're going to use our conversion factor to get over to some time units. 1 meter per 1 hour. Right, and now we just have to keep going until we get to years. And we know a bunch of different conversion factors to get to the correct time. 24 hours, 1 day, right? And 365 days in 1 year. And so the result is 517 years. So that little snail's going to be going for a very long time.